in the interest of time and because you're probably pretty tired, I'll just go over the key ideas of this and show you the code of some of our existing simulators. We actually have Kai recently wrote a nice template simulator interface, which we're hoping to merge in pretty soon, which you can also use as a baseline when you're implementing your own simulator interface, if there's a simulator you'd like to use that we don't already have implemented for. But the basic documentation on this, if you go to the main docs page, down under the libraries and simulators, we've got the page for supported simulators, and then we have interface into new simulators. And there are really two parts to this. One is defining the actual code, which takes the data from Scenic using the APIs we just saw, like to pull out the positions of the cars and so forth, and sends it over to the simulator to create the initial scene. And then also reads the updated positions, velocities, etc., back from the simulator to give it to Scenic. That's the first part, this using the Scenic API part. The second thing, which we may just talk about briefly today, is defining a world model. So we saw we have a generic world model for driving scenarios, but we also have a specific one for Carla and other simulators that we have. And basically, these world models have to define what already exists in the simulated world. So if there are roads or buildings, etc., that are going to be simulated, this is where you tell Scenic and the scenarios that people are going to write about those. So you can define concepts like, okay, we have the concept of a car in this simulator, or if it's a robotic simulator, here's the type of robot that this simulator can simulate. You put that all in terms of concepts that Scenic understands, like classes of objects and things, so that those can then be used when people are writing scenarios for that Scenic. Okay, so let's look at each of these in a bit more detail. This page has links to a bunch of the details on this, so I'm just going to show some examples. I've locked up Chrome. Okay, I froze Chrome, so I'll restart that. There we go. Okay, so from this page, you can see here, if you want to support dynamic scenarios, you have to implement a subclass of this class called simulator. So if we look at that, it's over there. So the idea of simulator is this is basically the representation of a connection to an external simulator from inside Scenic. So we have subclasses of simulator for Carla, Leadbots, etc. And basically, all that this simulator class provides is this simulate method that we saw before for running a simulation. Scenic actually defines this method, so you don't have to implement this. What you do need to define is this abstract method called create simulation. So for every simulator, we have a subclass of simulator, and we also have a subclass of simulation. So the simulation class represents a particular simulation that you can have. And so we also have classes like Carla simulation to represent a simulation run in Carla. So you have to override this create simulation method to return more specialized subclass. So if you're doing an interface to the food simulator, you would implement this to return a food simulation. And then what your food simulation subclass should do, you go to simulation, you have to implement at minimum 3 methods. These are the 3 basic APIs that any simulator interface needs to provide. One is to create an object. So a method called create object in simulator. We'll take a look in more detail at this in a second. So that's to create an object. So basically Scenic says, okay, I want to create an object at this position, with this velocity, etc. Translate that into API calls to the simulator. That's what this method does. Then there's a step method which advances time in the simulator. So this Scenic calls this to tell the simulator, please simulate 1 time step worth of physics. So if the time step is 1/10, this would be saying to Carla or Weebots or whatever, simulate physics for 1/10 of a second, then pause again, and so Scenic can read back the new state of the world. And it does that using the third of these methods, get property, which is called to get the new values of the properties for a particular object. So certain properties, if you see the list of properties in the documentation, are designated as dynamic properties. These are the properties that get updated every time step by the simulator. So these are things like position, velocity, etc. Whereas things like shape, width, and so forth, right now, those don't get updated, those are fixed. If you have a simulator where the objects are not rigid, let us know. So that would be different. But for right now, anyway, the basic things that get updated are basically the orient pose of the object, and potentially extra things that are specific to the simulator. Like our interface to Weebots, for example, lets you keep track of the battery life of a robot. So the battery life might be updated. Okay, so these are the 3 key methods that you have to implement in any simulator interface. So just to look at each of these in a little bit more detail, create object in simulator does what it says. It creates a given object in the simulator. So it's passed as an argument of Scenic object. So we saw this Scenic object class earlier when we were looking up like the position of that car object using the API. That was an instance of object. And this should call whatever simulator APIs you need to create that object. So it can look up the position, velocity, etc., and translate all of those things. So if we look, for example, at our Weebots interface, actually, let me get a card of mine. Here's the implementation of create object and simulator for Carla. So if you want to define this, this is in source, Scenic, simulators, Carla. We'll talk a bit more about the organization of the code tomorrow when we do Scenic's internal. And simulator.high, this defines the Carla simulation class. So this is a subclass of the simulation class. And inside create object and simulator, it's first doing some Carla specific stuff to figure out what type of object is supposed to be created. So Carla uses this thing called blueprints to identify objects. So it's just looking that up. Then it's doing some coordinate conversions. So Scenic's coordinate system and Carla's aren't quite the same. So we have to convert the position of the object in Scenic into whatever it should be in Carla. Same with the rotation. And then here's where we actually create the object. So that, the details here aren't important, but basically this is a Carla API to say create an object. And if that fails, we raise an exception to tell Scenic we were unable to create this object. Otherwise, we're going to configure this object. So, for example, like in the case of vehicles, we need to say things like we're going to do gear shifting manual. So, any kind of simulator-specific setup, you can do that kind of thing. So that's this first method that you have to basically take a description of an object in Scenic and implement it over in the simulator. Questions about that? Okay. The second one is simpler in some sense. This is step, which just runs the simulation for one time step. So this is usually pretty straightforward because there's usually a call on the simulator side that does exactly this. So if we look for step in here, it's basically just that. Carla has some API to run physics for one time step. We're actually doing a little bit more there because here we also, if you turn on rendering, which is on by default, it will show the little window you saw before showing what's going on in the scene. So there's some extra stuff for that. But that's basically what this method does. Just tells the simulator, okay, run physics for one time. Okay. So this actually, there was a question earlier about time steps. So it looks like here we're telling Carla, we told Carla ahead of time how long the time step should be. In some simulators, you can tell it at the time you take the steps. So actually, if we look in the Webox interface, here, its step method, you actually have to tell it how long to run it for in milliseconds. So here we're taking the Scenic time step, which is in seconds, turning it to milliseconds, and then telling Webox to simulate this much physics. So that's a slight difference between Webox and Carla. Okay. Finally, we have get property. So this one, given a scenic object and the set of properties you want to read back, which are going to be strings like position, velocity, etc., it's supposed to return a dictionary which tells you what are the current values of those properties in the simulator right now. So if we go back to look at Carla, for example, here's get properties. And we're calling Carla specific APIs like this get transform, get velocity, etc., to get all this information out from the Carla side. And then we're doing those coordinate conversions now in reverse from what Carla is representing back into Scenic. And then we're returning this dictionary of all of those properties. In the case of the Carla interface, the properties are actually fixed with dynamic properties. So it's just these: position, velocity, speed, original, and something. This is basically the minimum you need to get a simulator interface working. You have to be able to create objects, you have to be able to advance time, and you have to be able to read back the current state of it. So if you can figure out for your simulator what the APIs to do those things are, then you can write one of these interfaces. There's other stuff you can do. So for example, the Carla interface has some global parameters like the weather, for instance. So if you look at the Carla model, here's the Carla world model, scenic.simulators.carla.model. This is a Scenic file. This is the world model that you would import in every scenario designed to work with Carla. And it actually has doc string describing these things. Why don't we actually go to that? So if we go to supported simulators, Carla, here's the Carla world model, linked to right here. If we go to that, you can see the global parameters that the Carla world model supports. So for example, the weather. So if you want to control the weather in a scenario, you set this global parameter called weather. And there's documentation there about what kind of value it should have. If we then look at how that gets used in the simulator interface, file. This is actually getting used in the setup method, which is an optional method the simulator interface can implement if there's one-time setup you need to do at the start of the simulation. So things like setting the time of day, setting the weather, those have to happen at the start of the simulation, but they're not associated with any particular object. So you could implement this setup method, which Scenic will call once at the beginning of each simulation. So here in the Carla interface, for example, we're taking the scene that we're generating the simulation from, looking at the parameters dictionary that we saw earlier, and seeing, is there a parameter called weather? If so, we interpret it as a string or a dictionary, and we call some Carla-specific API to deal with that. Time of day, likewise, must be handled here somewhere. I'm not sure where that is. I'm not sure where that is. You have to go find it. But that's another place that you can optionally implement things. The setup method, if you need to do one-time initialization at the beginning of each. So any questions about simulator interfaces?
I mean, as a suggestion, so this might feel a little abstract so far, but if you're already using a simulator supported by Scenic, like Carla, just go into the Scenic repository, go into source Scenic simulators, and then look at the code that's written for the simulator you're using. And that will give you a very complete idea of how the interface is done.
Yeah,
And
absolutely.
if you haven't used any simulator yet, just look at the Newtonian simulator.
Well, I mean, the Newtonian simulator, you can look at the Newtonian one. That one, you have to keep in mind, is a little bit different because that one is not communicating with an external simulator. So it has code in it to actually like compute the change in velocity of a car or something, which normally an interface would not have to do because the physics engine in the simulator is doing it. But if you'd like to look at examples, they're linked from the documentation. The ones I recommend most are the Carla and Weebots ones. They're relative; those are the most fully featured dynamic interfaces that we have in there. And once you understand what these top-level functions are supposed to do, which is explained in this page, the description of all of these methods are in the documentation here. It's relatively straightforward to see what's going on in the code. Okay, so the last part that I want to mention, we go back to interface new simulators. The other part, besides writing that Python code, basically to go back and forth between Scenic and the simulator, is the world model. So I wanted to look into one of these world models in a little more detail, just so you can see what that looks like. If you want to help people write scenarios for a new application domain, for example, you might be writing one of these world models, or if you're doing a new simulator. So let's look at the Carla model and see what kinds of things are in there. So it says here the kinds of stuff you might want to include are scenic classes corresponding to different types of objects. You might want to have regions that people would use in scenarios. So for example, if you're doing driving scenarios, you need to be able to talk about lanes and roads and curbs and so forth. So the driving world model defines all of those things. Also actions. So remember when we talked about dynamic behavior before, we said the atomic actions like steering, throttle, etc. Those are defined by the simulator interface because they tend to vary depending on your application domain. So if we look, for example, at the Carla model, just to see what that does. This is the Scenic world model for traffic scenarios in Carla. Bunch of imports. So the first thing that this does is it defines some global parameters that the interface can use to configure the simulation. So for example, you can actually say where to connect to Carla. If you want to, if Carla's running on a different machine, for example, whether you want to render or not, if you want to run in like a headless mode where you won't render anything, you can do that. Here's the weather parameter we talked about. So here it says, weather is a global parameter. The default distribution for it is a uniform distribution over these like 12 different kinds of weather. But a particular scenario can override this with a different distribution. And we saw in the code for the simulator that it's going to look for the value of this parameter and then call the Carla APIs to set up. So, yes.
I think you guys can set it with more specific.
You can, right. So actually, here, if we go back to where this gets used, if it's a string like one of those, we use this. But you can also pass a dictionary that has like all these detailed parameters. So this interface supports both. Okay. Then this is rare statement that we didn't talk about before because this is mainly used inside world models. The simulator statement says what is the default simulator that scenarios using this world model should use. So this is saying the default simulator, if you're using this world model, is a Carla simulator where we're passing in all this information from some of these global parameters. So this global parameters thing here is the way in Scenic to access the value of a global parameter inside the Scenic program, which you don't that often need to do because usually they're data that goes to the simulator. But if you need to access it inside the program, you can use this global parameters dot and then the name. So here we're saying, for example, the Carla simulator actually requires you to specify the time step ahead of time, for instance, but we're passing that in there. Then another common thing you would do in a world model is define the classes of objects that the simulator supports. So here we have an abstract class called Carla Actor, which is basically extending the object class that's built into Scenic, actually the driving object class, because this implements Scenic's abstract driving model, which we won't get into here, adding Carla specific stuff. So here we're saying, for example, blueprint is a Carla specific property saying what type of object this is. Is it a trash can versus a lamppost, whatever, right? So Scenic doesn't know about blueprint. So we have to add that in here so that if you then write a scenario talking about blueprints, it will be runnable in Carla if you use this world model. Okay. We can also define other methods and things on here. What these are doing is actually defining some properties or setting some velocity and position of objects, which some of the actions in the driving domain will do. We can ignore that. Here's a abstract class of vehicles, and we get down to an actual concrete class, like here's the definition of car that we saw earlier. Here, it's basically the same as a vehicle that we saw before. The only difference is it declares itself to be a car with this property here, and it puts a different default distribution on the blueprint parameter. Here, it's uniform distribution over all the car models that Scenic knows about, which we're importing from some other model. And we can define all kinds of utility classes, like for bicycles, motorcycles, different types of objects. That's all. So then a scenario written using this library can then talk about bicycle object, and it will refer to these class definitions. So that's, I think the rest of this one is mostly that. We have some helper functions too. So for example, I mentioned before, Scenic doesn't know about traffic lights. The driving domain of Scenic doesn't yet talk about traffic lights. But Carla has traffic lights. So we put some helper functions in here to help you control the traffic lights if you're writing a scenario involving that. Okay, what else should be defined in a world model? The main missing piece I haven't shown yet are the actions, the primitive actions, like steering, throttle, and so forth. The reason we didn't see them here is that they're actually being imported from another file. We separated them out into another file just so that this file doesn't get too long. So if we go over to actions.py over here, these are the definitions of the actions that the Carla interface supports. So for example, let me go down to a more interesting one. Here we go. In Carla, it actually models the gear shift, which the abstract driving library in Scenic doesn't support. Yeah. So here we've made a new kind of action called the set manual gear shift action. And what it basically does is in this apply to method, Scenic calls this when a behavior has requested, we use a particular action for a particular object. And this needs to call the simulator specific APIs to implement the action. So in this case, we are calling some Carla APIs here, basically to specify what we want the manual gear shift. So you can define actions like this. You can also define behaviors. So the driving domain in Scenic provides a lot of behaviors like the lane follower behavior I mentioned before. But we also can have simulator specific ones, like it came up before. If you want to use Carla's autopilot to say this car is controlled by the autopilot, we have a behavior for that. So here is a behavior called autopilot behavior. But actually all it does is it calls this set autopilot action. And that's defined somewhere else. Over here, I think we can find that. There you go. It just calls the Carla API to say, use the autopilot for this vehicle. So that's an example of a simulator-specific action that doesn't make sense outside of Carla, but you can define that in this world model so that scenarios written for Carla can use them. I think that's basically it. So these are the kinds of things you would see in the world model, basically just utility classes, regions, actions, and utility functions that will help people write scenarios for that simulator or that application domain. So if you'd like to look at these in more detail, you can look at the Carla world model. The driving domain model might also be an interesting one. So this is the world model for the driving domain. It doesn't assume anything about the simulator really, but it defines concepts like car, etc., lanes, etc., that are transferable across driving lanes. Okay. Any questions on interfaces or world models? Yes.
I mean, the next visualizer are the lines from the XOPR cloud on front.
Yeah, right. So the question was in the Newtonian simulator when you saw like the pictures of the lanes and things behind, where are those coming from? Those are being imported from the OpenDrive file. So actually here in the driving domain is what defines, is what looks for this map global parameter. So you saw in some of the examples, you could say like para map equals something, something, something of XODR, like here. We're saying, this is the road network I want to use. It's given by this OpenDrive file. Here is where we're actually looking for that. We're saying, if there's no map parameter defined, raise an error saying, hey, you have to say what driving network you want to use. Otherwise, we're going to actually call some other function here to import that, to load that file, extract the polygons for all the roads, etc. This is done elsewhere in Scenic. And it returns this network object, which we expose if the simulation wants to, if the scenario wants to refer to it. And then we pull things out of that, like here's the curve region we saw in the magnet park car scenario. Here's where that's defined. It's the curve region pulled out of this road network. Any other questions? Okay, well, I know we went over a lot of stuff here, so if you come up with questions later, feel free to let us know. All of these things are documented on our website too, but feel free to post questions on the forum or come talk to us if anything comes. I mean, later after the workshop, please feel free to post in the forum if questions come up that you can't find the answer to in the documentation.